Hi folks, it's Calc 3, Quiz 16. We're asked to write a triple iterated integral in an appropriate coordinate system which would determine the volume of the indicated solid. So number 1, we're asked to look for the solid bounded by the graphs of z equals 1 minus y squared, x equals 4, the first octant. So let's go ahead and try to visualize this solid. Let me draw here the first octant, x, y, z. Z equals 1 minus y squared. In the yz plane, that's a parabola, vertex at 0, 1, opening down. I'm only going to draw the part, though, that's in the first octant. The x is free, which means we're free to wish this out and back as far as we want to go. How far do we want to go? We're going to go up to the plane x equals 4. So at x equals 4, we have another one of these guys parallel to it. And I think you can kind of visualize the solid we're looking at there, Q. Now, when we have a triple integral, and we're going to use rectangular coordinates, it's helpful to think of the innermost integral as integrating over the height, and the outer two integrals integrating over the base. So where do you want the base of this solid to be? Well, there's a couple of really good choices. Actually, there's no real bad choices here. So I'll just make the base in the zy plane. Which means the height is going to be the variable left over, which is going to be the x. Oops, that's height. So for my triple integral v, I'm going to have a double integral over the base times an integral for the height. 1, the height variable's x, and I haven't chosen the order then on the dA for the base. So let's take a look at the base a little more closely. I know this is 1 unit out and 1 unit up. So a good integration order for that would be dz dy. So v equals the integral. If I'm going to do dz dy, I'm chopping up the y from a constant 0 to a constant 1. For a fixed y, what does the z run between? It starts down here and goes up to that curve. So that's z equals 0 to z equals 1 minus y squared. And I'm integrating the height. Well, the height is the x direction. So this is what the height is. It starts back here at x equals 0 and goes up here to x equals 4. 1 dx dz dy. And so that's number 1. Number 2, we're looking for the solid bounded by the graphs of y equals x, z equals 0, z equals 3, and x equals square root y. Well, y equals x, in the xy plane, that's just a line that's going to go out and back. But the z is free, so it's actually going to generate a plane. Z equals 0, that's another name for the xy plane. Z equals 3, that's the xy plane shifted up 3 units. And x equals square root y, well, that's the same as y equals x squared. And it's going to come out like that. Okay, so what's really happening here? Well, if I look at what's going on between these two graphs, I do get a little slice of area in here. Okay, but once again, the z variables are free in these two equations, which means we're actually free to move these things up and down. So we kind of get a solid, that comes from this kind of cylinder here. Okay, so imagine this little piece just moved up and down between z equals 0 and z equals 3. So that tells us that a good base would be the xy plane, and the height then is going to be the z. So if we look at the base, we have y equals x. We have x equals square root y. The height then, as we mentioned, is going to be the z. So what's the volume going to be? Well, as before, we're going to take a double integral over the base, integral over the height. 1, the height here is dz, and then we'll determine the order for the base here in a minute. It really doesn't matter which one we use. We can go ahead, since x is given as functions of y in both of these things, we can look at where these things intersect, which is going to be at 1, 1. And we can go ahead and use the order dx dy. So if I'm using the order dx dy, I would chop y up from 0 to 1. And then for a fixed y, the x runs between what two things? This line over to that curve. This line is given by x equals y. This curve is given by x equals square root y. And now the integral on the height goes from a constant 0 to a constant 3. 1 dz dx dy. So that'll do it for number 2.